Let's look at the UCS. What we see here is the chassis that I described earlier. The chassis houses the power supplies. We have power supplies 1, 2, 3, and 4. And we have up to 4 full-width slots or 8 half-width slots. Now, it doesn't mean that I have to have all halves or all full. I can have a combination of the two. As you can see here, we have 4 half-width blades and we have 2 full-width blades. Now, the chassis is little more than just a box that houses the individual blades and the power supplies necessary to allow them to operate. The really important part to us right now is the greenish gray module on the top. This is the fabric interconnect. The fabric interconnect is the stepping off point into the SAN environment, into the LAN environment, and it's also the primary pathway that the servers have to communicate with assets in those arenas, and also to allow assets in those arenas to communicate to the servers. Now, what I'm going to do is I'm going to flip this over, and we're going to look at it from the back. What we see here is the front, but if I look at it from the rear, what we're going to see is we're going to see a series of fans. There's 8 fans. You can see the back of the power supplies where the power modules or the cables plug in. And we have the ports on the fabric interconnects that we have connected. Now, I don't want you guys to get confused. This looks like there are 2 fabric interconnects, when in fact this is actually a single fabric interconnect. This is a Cisco C6296 fabric interconnection module. Now, this fabric interconnect is twice as large as the other alternative, which is going to be the 6248. So let me see if I can bring up a 6248 so that you guys can see what it looks like. And as you can see, it's half height. Now, this works really well for me because what I want to do is I want to use this as an opportunity to demonstrate the nature of connectivity into the different areas that we've discussed. Now, what I'm going to do is I'm going to zoom in on this. And by zooming in, there we go. What we see here are the 32 ports that are fixed on this particular module. These are the 32 ports that are part of the Cisco 6248 UP. Now, the emphasis here is on UP. Now, the reason I'm bringing this up is because UP stands for Universal Port. Now, what that does is that states something very specific about this fabric interconnect. This fabric interconnect can support different types of connectivity. I could take a transceiver, something called a small form factor pluggable module, and I can insert it into these slots 1 through 32. And based on the SFP that I'm using, this port could operate as either a fiber channel port, meaning native fiber channel, or it could be an Ethernet port. Now, the thing that I need you to understand is that if I do use fiber channel ports, they must begin on the right side of the module. So if I want to use fiber channel in slot 29, that implies that slot 29, 30, 31, and 32 are all going to be fiber channel ports. Now, this is referred to as a 6248, and we read 48, meaning 48 ports, and what I see here is only 32 ports. Well, I can get the additional 16 ports if I choose to employ something called a GEM, or a generic expansion module. Now, these modules in the 6248 are also considered to be UP. You can see here it is referred to as a UCS-E for expansion, 16 port universal port, or 16 universal ports. Now, these can operate at either 1 gig or 10 gig. They can also operate as fiber channel ports. Now, we're going to learn that our speeds in fiber channel are typically going to be 1 gig, 2 gigs, 4 gigs, and 8 gigs. This particular unit does not support 16 gig transceivers for the purposes of our SAN connectivity. But the reason that I'm stressing this is that it's this module here that is going to provide the UCS assembly connectivity into the actual data center. Now, that begs the question, what type of devices are we going to be connecting to in this data center configuration or data center topology, and that's what we want to look at now. And what we're going to do is we're going to begin with an exploration of the components that we're going to use on the data side. Now what we're going to find is that's going to fall into the category of the Nexus line of devices, and those are the only ones that we're going to focus on, and they're going to be in 3 different types. We're going to focus on the 7000, we're going to focus on the Nexus 5500, and we're going to focus on the Nexus 2000 series device, which is what we call a fabric extender. So let's take a look at each of these in turn. The Nexus 7K. The 7000 series Nexus switch devices are considered to be the thoroughbreds of their category. The throughput capacity that they give us is second to none in any of the switching environments that you're ever going to operate in. The 7K is typically going to be found in what Cisco defines as the core or the aggregation layer of our data center model. Now, the key element here is this device provides both switching and routing capabilities. However, given the fact that it's ordinarily positioned in the aggregation layer, we do not traditionally find UCSs connected to 7Ks. Now, the scenario here is that we have to recognize that we have, from the networking side of the house, the requirement to find the right tool for a given job. So I don't want to spend a tremendous amount of time on the 7000, but it is important that we look at it from the point of view of the possibility of using it for connectivity to our UCS. What we can do is we could connect a fabric interconnect, whether it's the 6248 or the 6296 UPs, to any of the line cards found in this particular device. Now, this device is comprised of 2 supervisor modules. It's also comprised of a number of line cards that give me the capability of having, like I said, both routing and switching capabilities in my infrastructure. It also allows me to support something called a virtual port channel or traditional port channels. This means that I can actually have, if I use a virtual port channel, more than one of these particular devices operating in such a fashion that they're pretending to be a single switching fabric. And that pretense is extended all the way down to the fabric interconnects that we saw in the previous portions of our discussions. Now, the 7K is not the principal go-to switch that I would connect fabric interconnects to. If I'm going to connect them to a parent switch, typically I would connect them to a 5000. Now, the 5500 series switches are going to be the ones that we're going to look at specifically in this portion of our conversation, and the reason being is that they're considered to be the second generation end of row switch that we have, that we are currently deploying in data centers today. Now, I'm not going to do too much with the 7000. It is important for us, however, to recognize the fact that the 7K gives us bandwidth, the likes of which we've really never seen before, especially in data center environments. So we've seen a 7K. Let's take a look at exactly what a 5K or a 5500 looks like. The next data center switching device that we need to really focus on is going to be the 5500. What we see here is a 5596 UP. That means this particular device can support up to 96 individual unified or universal port configured SFPs. Now, the wonderful thing about the 5500 is that it's, again, very similar to the 7000 that we discussed previously, but it's really purpose built for layer 2 communications. It also supports the same capabilities as the 7000 does when it comes to working at layer 2 Ethernet switching. That means it's going to do port channels, the traditional version of port channels, and the idea of a multi-chassis Ether channel configuration, or what we refer to as a virtual port channel. 2 switches pretending to be a single switch to everything below them or above them. Now, the scenario here is the 5596 is the larger of the 5500 series devices. Specifically, we'll deal with the 5596 or the 5948, but I decided to use the larger one to illustrate exactly what a typical end of row switch would look like. Now, the 5500s could act as end of row in unison with another device that we're going to be talking about here shortly called a fabric extender, or they can be top of rack switches, which means the FIs could connect directly to them. Now, the cool part about that is again, by virtue of the fact that the 5500 supports the idea of virtual port channels, that means it's going to expand my high availability capabilities because my clusters are going to be operating in what is referred to as active forwarding for data. So I'm going to have two fabric interconnects per UCS cluster, and both of those interconnects are going to be sending data and able to receive data that's coming from the Ethernet aspect of my data center. Now, when we look at this device from the front, what we're going to see is the fact that we have two power supplies, and we have a series of fans, and we also have a series of connections that we're going to use to administer this device. Since this is a standalone switch, it is going to be a point of management. So for every 5,000 that I have in my infrastructure, and for every 7,000 that I have in my infrastructure, I'm going to have a minimum of one point of management. Now, when we look at this from the rear view, we see our modules. The bottom row consists of 48 individual ports. These ports, since they're UP in nature, have the capability of being able to work with both fiber channel as well as Ethernet and support the concept of fiber channel over Ethernet. So what we're going to find here is this device in its as is configuration simply gives me the capability of being able to support almost everything that I need to support. So I can have the ability to support native fiber channel. I can have the capability of supporting Ethernet. And like I said, I have the capability of supporting fiber channel over Ethernet. This switch is a very, very handy item to have in our toolkit when it comes to building a data center, and probably 9 times out of 10, a fabric interconnect will be connected either directly to a 5000 or indirectly to a 5000 by virtue of having a 2000 or a Nexus 2K connected to a parent 5K. That's going to be our typical design. Where the 7000 predominantly existed inside of the aggregation and the core layers of our data center design model, the 5500 exists at the aggregation and the access layer. The access layer is going to be where we find our UCSs. So again, think of these like building blocks for putting together our data center. The 5500s ordinarily will be connected to the FIs directly or indirectly, depending on whether or not we have a 2K involved. And these devices are going to work principally at layer 2. The 5500 does have the capability of being able to support what is referred to as a layer 3 daughter card. And that layer 3 daughter card gives me limited layer 3 routing capabilities inside this one particular piece of equipment. Much smaller, much less expensive than a 7K, but has a lot of the same capabilities, sans the massive amount of throughput that we get inside of the 5K. Also, later on, we'll discuss the concept of virtual device contexts. When it comes to the 7000, just bear in mind that virtual device contexts do not exist in the context of the 5500s. Now, 5500s very rarely are going to be operating in what we could refer to as a singleton deployment, or where I have just 5Ks. More often than not, we employ 2000s, Nexus 2Ks in concert with the 5500s. And the primary reason for doing this is the fact that a 5500 has a lot of robust capabilities, but it really does have one Achilles heel. That Achilles heel is the fact that it doesn't have a tremendous amount of port density. The 7000 supports multiple line cards. We could have a line card with 48 ports, with 32 ports, or even more ports. So the 7000 gives me a very small profile where I can have a high density of ports. 5K gives me a very small profile, but it really only supports a reduced number of total ports that I can employ in my environment. And that's what brings the 2K into play, because the 2K has the capability of acting like a remote line card for a 5K. And it really should come as no surprise when I tell you that a 2000 can also be used in concert with a 7K. So you can see how these individual building blocks can be arranged in such a fashion that we can customize our data center for the purposes of ensuring that we have ample bandwidth and all the possible or necessary fabric to allow data center and Ethernet communication to move freely throughout our infrastructure. So, having taken a close look at the 5500, all I want to do is show you guys a 2K, and then what we'll do is we'll wrap this particular portion of our lesson. Honestly, there's really not a lot to the Nexus 2000 series devices. Ports are going to be divided into two categories: what we refer to as host interfaces, interfaces that are pointing towards devices that need connectivity to the infrastructure, and what we call network interfaces, or sometimes referred to as uplink ports. Uplink ports connect to parent switches. The really interesting thing about 2K is the fact that the Nexus 2000s have zero intelligence integrated into their housing. They must be connected to a parent switch, irregardless of whether that switch is a 7K or a 5500. The point is that it's going to be the parent switch that provides both the kickstart image and the operating system to its connected 2K. Now, the point here is the fact that the moment that I connect a 2K to a parent switch, the 2K will be managed from the parent. There isn't even a single interface on a 2K that I can use to manage it. There is no console port, there is no management port. The only thing that exists are the two ports types that I described earlier: uplink ports or network interfaces, and my host interfaces, sometimes referred to as HIFs. Now, the main thing to realize here is that I can have dozens of 2Ks. In fact, I can have, in some instances, anywhere from 28 to 64 Nexus 2000s connected to a single parent switch. And the really important thing to focus on here is the fact that all of those 2Ks will be managed from the parent. So if I had 65 Nexus 2000s, I would still only have a single point of management, where for every 5K and for every 7K, as I said earlier, we would have a minimum of a single point of management. Nexus 2Ks are all going to be managed from their respective parent switch. So that's the primary thing I want us to pay attention to here. And by virtue of the fact that these devices can connect to 5Ks, it's only natural that we cable these in what we refer to as a top of rack design, where the 2000s are going to be located in the same cabinets with the UCS's fabric interconnects. And then what will happen is every one of the 2Ks will be connected to their parent 5K via their corresponding uplinks. So now what you can see here is the fact that I have multiple UCS chassis connected in such a fashion that I have high availability design going back to at least two 5500 switches. So that's going to be what we describe as the top of rack, where the 2K is the top of rack device and the 5500 is referred to as the end of row device. This pretty much wraps up our introduction to the data center Ethernet connectivity, and it's time for us to really start moving our attention towards the storage area networking interconnectivity. You're going to find out that we're going to see some of these devices again, because all of these have the capability of supporting both Ethernet and fiber channel connectivity. However, bear in mind, we will see that we have a new type of device that we're going to pay attention to when it comes to storage area networks, and that's going to be what we call the MDS, the multi-director switch series. I'll see you guys in that part of the lesson.